Jai Hind students, experiment, fail, learn, and then repeat. It describes a continuous growth cycle where one attempts new ideas, accepts that mistakes will happen, gains insights from failures to adjust the approach, and then tries again to improve and achieve success. This mindset emphasizes that failure is not an endpoint, but a necessary part of the learning and innovation process leading to progress through trial and error. In this experiment, we will determine the resistance of a galvanometer by half deflection method, and we will find the figure of merit of the galvanometer. In order to perform this experiment, we'll be requiring a source of EMF. In all experiments on electricity, a source of EMF or a source of current is a must. Then we'll be requiring galvanometer, one-way key, and resistance boxes. A resistance box has a large number of resistance coils all connected in series, and we'll be requiring connecting wires as well. So in order to perform this experiment, the requirements are a galvanometer, then we'll be requiring a source of EMF, we'll be making use of a battery eliminator, or we can make use of a normal battery. Then we have to have two resistances boxes, one acting as high resistance. So it will be a resistance box of high range. So this is high value of resistance. Let us denote it by R, capital R. And another resistance box, it's of low range. So this will act as a shunt. So we'll denote it by S. It is to be connected in parallel to this galvanometer, right? And these are the two one-way keys. And obviously we'll be requiring connecting wires. So students, you are aware, a galvanometer, it's a device which is used to detect small electric current in a circuit, right? And it has a coil pivoted in a radial magnetic field. Now when current is passed through the coil, then obviously it gets deflected. And the deflection of the galvanometer is noted by attaching a pointer to the coil. This deflection, as you're aware, is proportional to the electric current passed. So the more the electric current passed through the galvanometer, the greater will be the deflection shown, right? So normally, this is the circuit diagram to determine the resistance of a galvanometer by half deflection method. So initially students, we will only close key K1 and key K2 is open, right? So let's try to determine the mathematical formula to get the resistance of this galvanometer. G, suppose it's the galvanometer resistance. So let's find out the resistance of the galvanometer by using half deflection method. As I've told you, this is the appropriate circuit diagram, right? Now let us consider the current flowing is I. And as you are aware, just now I've told you, the greater the current made to pass through the galvanometer, the greater will be the deflection, right? So I is equal to K theta. K is some constant. Now in case K2 is open and K1 is closed, then total resistance of the circuit, R and G, are connected in series in case K2 is open. So total resistance when key K2 is open, then the total resistance in the circuit is R plus G. And we are aware, students, the current flowing through the circuit, it will be equal to net EMF divided by net resistance. So net EMF is suppose E. So it will be net EMF over net resistance is R plus G. Now this is the case when K2 is open and only key K1 is closed, right? So therefore, from these two, what we get is E divided by R plus G, it would be equal to K theta. Let us assume this to be equation number 1. Now students, what to do is, we will insert this key K2 and we need to adjust this value of shunt resistance so that the deflection, it reduces from theta to theta by 2. That is what we call as half deflection method, right? So now, key K2 is inserted. And as I've told you, we need to adjust this value of shunt resistance so that the deflection in the galvanometer becomes half, that is theta by 2. Now when K2 is inserted, then total resistance of the circuit, it will be given by total resistance of the circuit when key K2 is closed. Then total resistance of the circuit is, look, G and S, these two are in parallel. So the parallel grouping of G and S would be GS divided by G plus S. And the combination of these two, it's connected in series with this high resistance R. So net resistance of the circuit would be definitely R plus the resultant of these two, which are connected in parallel. So it would be GS divided by G plus S, right? So accordingly, now the net current flowing through the circuit would be, in this case, current I, it would be equal to, again, EMF over net resistance. The EMF is same, that is E. We are using the same source and the same voltage. So net EMF divided by net resistance. It is R plus GS divided by G plus S, right? This is the net current. This is the net current I. Now, as we are aware, only a safe value of current can pass through the galvanometer. Let us consider it to be IG. IG is the current which is made to pass through the galvanometer, for which the galvanometer shows full scale deflection, right? So applying junction rule over here, we get I minus IG is the current which is passing through the shunt, isn't it? So the current IG, it will be given by, now that can be found by using the fact that these two are connected in parallel. And in parallel, students, the potential difference is constant. That is, potential difference across G, it would be equal to potential difference across S. So potential difference across G is IG. It is the current for which the galvanometer shows full scale deflection. Resistance of the galvanometer is G. And PD across S would be equal to current passing through the shunt resistance is I minus IG multiplied by S. So from here, after rearranging the terms, we can easily obtain the value of IG. So students, IG would be, just rearrange the terms. So the current which is flowing through the galvanometer, or rather the safe value of current, it is IS divided by G plus S, isn't it? So IG, as we have determined, it is equal to IS divided by G plus S. Now students, what we can do is, we can substitute this value of current I over here. So what we get is E divided by R plus GS divided by G plus S. That's the value of I, which is the net current, right? Multiplied by S into G plus S. Okay. So IG, just mathematically proceeding, what we get is ES divided by, this G plus S and G plus S, it will get cancelled. Taking LCM, we will get R G plus S plus GS. So students, this is actually the current that produces a deflection of theta by 2. Let me repeat. After inserting key K2, we need to adjust the value of shunt resistance so that the deflection, it gets reduced from theta to theta by 2, isn't it? So when current I is made to pass, then the deflection is theta. When current IG is made to pass through the galvanometer, then the deflection should be theta by 2. So therefore, ES divided by R into G plus S plus GS. This is actually IG. And this is the current which produces a deflection of theta by 2. So if this current produces a deflection of theta, therefore current IG, it produces a deflection of theta by 2. So put this as equation number 2. So students, from equation 1 and 2, what we get is, okay, so equation 1 is E over R plus G equals to K theta, and this gives half the deflection, right? This is for corresponding to current IG. So from first and second, what we get is E divided by R plus G. It's equal to K theta. Now K theta equals to twice ES divided by this term, right? So it will be twice ES divided by R G plus S plus GS. Now students, we need to mathematically solve it and rearrange the terms, and we can easily get the value of the galvanometer resistance, which is capital G. So EE get cancelled. So we are left with R into G plus S plus GS is equal to, cross multiplying we get twice S R plus G. So simply let's open the bracket, and by following simple mathematical steps we are supposed to obtain the value of galvanometer resistance. So that will be the working formula. We need to get the value of G, right? So what we do is RG, RS plus twice RS. So we'll be left with only RS. GS, and this is minus 2G. So GS minus twice GS, it would be minus SG. That is or the galvanometer resistance is given by RS divided by R minus S. And students, this is the working formula. Now look, experimentally, we are aware of this value of R, which is the resistance which is taken out from the resistance box of high resistance range, right? S is the shunt resistance. This is the second resistance box having low range of resistance. So experimentally, we will be able to know the value of R and S. So knowing the value of R and S, the value of capital G, which is the resistance of the galvanometer, that can be easily determined. Now students, this is the working formula and this is the observation table. And this column represents the high value of resistance, right? Corresponding to which the deflection of the galvanometer will be theta. And then we need to adjust the value of S, which is the shunt resistance, so that the deflection of the galvanometer becomes half. And by using this working formula, we can calculate the value of galvanometer resistance. So now students, let's take out the reading in various cases. A galvanometer is a device used to detect small electric current in a circuit. It has a moderate resistance and has a very small current carrying capacity. The resistance of a galvanometer can be found by using half deflection method. The circuit diagram for this method is as shown. First and foremost, key K1 is inserted while key K2 is open, and deflection theta is determined with a suitable value of resistance. Now let us take the first reading. As we are aware that a source of EMF is required, so we are applying an EMF of 2 volt and we are introducing a resistance of 4000 ohm from the resistance box R. We need to ensure that key K2 is open while key K1 is closed. Now you can check the deflection of the galvanometer. It is showing a deflection of 20 divisions. Now we need to insert key K2 also, and without changing the value of capital R, we need to adjust the value of capital S, that is the resistance from the another resistance box. By taking out the shunt resistance S equals to 70 ohm, we can easily check that the deflection of the galvanometer is 10 divisions. Now let's concentrate on the second reading. Here again, the EMF is considered to be 2 volt, that is same as was in the first reading. And again, key K2, it should be open while key K1 should be closed. Now taking a total resistance of 5500 ohm, we need to see the deflection of the galvanometer, which is 15 divisions. Now we will repeat this step. Again, the key K2 is closed and the value of shunt resistance S is to be adjusted in such a manner that the deflection of the galvanometer reduces to exactly half the value obtained in the previous step. That is, we need to obtain a deflection of 7.5 divisions. So for that, we can easily check that the shunt resistance is to be 73 ohm. As you can notice, now the deflection in the galvanometer is 7.5 divisions. Now for the final and the third reading, we need to repeat the above steps. Key K2 is open while key K1 remain closed. We need to change the value of capital R and note the galvanometer deflection again. So, in this case, if we apply a resistance of 8500 ohm, then the deflection obtained in the galvanometer is found to be 10 divisions. Now, in the very next step, key K2 is inserted and the resistance from the shunt resistance box is so adjusted that the deflection in the galvanometer becomes 5 division. So we can see for S equals to 74 ohm, the deflection is 5 divisions. So these are the various readings corresponding to the value of R as 4000, 5500 and 8500. And these are the deflections corresponding to the value of capital R. As I've told you, the value of S is to be adjusted in such a manner that the deflection becomes half theta by 2. Here it's 20, here it's 10, 15, 7.5 and 10. Then here half deflection is 5, right? So this is the working formula. Let's obtain the value in the first observation. G1. So it would be RS. R is 4000 multiplied by S, shunt resistance is 70, divided by 4000 minus 70. Right? This is the formula. So on solving it, we'll get a value of 71.24 ohm. Similarly, students, G2, it would be equal to R into S. R over here is 5500 multiplied by shunt resistance over here is 73. So divided by 5500 minus 73. On solving it, we'll get 73.98 ohm. And in third observation, R is 8500. S is 74 divided by R minus S, that is 8500 minus 74. So on solving it, corresponding to the value of R as 8500, we get the value of galvanometer resistance to be 34.64 ohm. Now students, we repeat this experiment, or rather we take various observations so as to reduce the experimental error. So the method is, we obtain the mean value of G so as to minimize error, experimental error. So mean value of the galvanometer resistance would be, I'm talking about arithmetic mean, so it will be sum of all the observations divided by total number of observations. So this comes out to be 73.28 ohm. So this is how the value of the resistance of the given galvanometer can be easily found by half deflection method. Now students, in the second part of this experiment, we need to understand the concept of figure of merit. Now look, the figure of merit, we will represent it by K, and the figure of merit of a galvanometer is defined as the current which will be requiring to produce a deflection of 1 division in the galvanometer. So whatever current is required to produce 1 division deflection in the galvanometer, that is known as the figure of merit of the given galvanometer. Right? So we are already aware that I is equal to net current. It is E over R plus G. Isn't it? I'm talking about this circuit diagram. That is, this was considered to be the source of EMF, and we are considering only the key K1 to be closed. No requirement of the shunt resistance. So we are obtaining the figure of merit of the galvanometer, right? For this is the relevant circuit diagram. This is the resistance box of high range, which is capital R, and a galvanometer is to be connected like this. So this is the relevant circuit diagram. So here key K2 or the shunt, that need not to be connected, right? So in this circuit, the net current flowing is EMF divided by net resistance. Net resistance of the circuit is R plus G. And this, suppose the galvanometer shows a deflection of theta corresponding to current I, then it would be I equals to K theta. Here K, which is I divided by theta, that is the figure of merit. The current which is required to produce a deflection of 1 division in the galvanometer, that is the figure of merit. So obviously, its SI unit would be ampere per division, right? K is I divided by theta. So the SI unit is ampere per division. So that's the SI unit of figure of merit. Okay, so from here the value of K, it will be given by E divided by R plus G into theta. So students, this is the working formula. Now by varying the value of capital R and noting the corresponding value of theta, we can easily find a set of values of figure of merit, right? And then the mean of these values will give us the figure of merit. This is the observation table. This is the EMF, which in our experiment we have considered to be 2 volt. This is the value of resistances. This we have considered to be 4000, 5500, 8500, right? We have already taken the reading. And these are the corresponding deflections, 20, 15 and 10, corresponding to these values of R. So this is the working formula which we have derived. So simply we need to substitute the value, and then as I have told earlier, we need to take the mean of K. Friends, these are the values, we have already obtained it, and this is the substitution of the values in this corresponding formula, right? E, that is 2 volt, R plus G 4000 plus the value galvanometer resistance has already been determined earlier, which is 73.28, multiplied by theta. Theta corresponding to 4000 ohm is 20 divisions. So after solving, we get 2.45 into 10 raised to the power minus 5. Obviously, the unit would be ampere per division. Similarly, in the second observation, let's substitute the value E, which is 2 divided by R plus G. R over here is 5500 plus galvanometer resistance, which we have already calculated. That's 73.28 multiplied by theta. Over here, deflection is 15. So students, you can make use of the calculator and you can solve this value, and it comes out to be, I have already calculated it in the rough work. So it is 2.39 into 10 raised to the power minus 5. So it is ampere per division. So students, substituting the other values and getting the value of K corresponding to 8500 ohm, we get this value, right? And thereafter, so as to minimize the experimental error, we consider the mean of all these observed values. So the mean value of K is obtained to be 2.39 into 10 raised to minus 5 ampere per division. And the earlier result for the resistance of galvanometer was 73.28 ohm. So students, in this experiment, both the results has been obtained, right? Now, there are some precautions which we need to take while performing this experiment. On all the occasions during the noting down of the observations, all the connections should be neat, clean and tight. And you need to ensure that the plugs of the resistance boxes are tight, right? And also students, remember, initially a high resistance from the resistance box should be introduced, or else sometimes a small resistance can damage the galvanometer. So these all are the precautions which we need to consider while performing this experiment. So students, I hope you have learned a lot and you have cleared your concepts, and hopefully you will do this experiment in your respective physics lab sincerely and with full dedication, right? Thank you students, thank you for watching my videos, and keep watching my videos, and don't hesitate and don't forget to subscribe my channel.